Hello students and friends. So today we are going to talk about the charge on colloidal particles. In the previous lectures we discussed what are colloids, what are various types of colloids, and we also read that the charge is present on colloidal particles. Now charge can be positive or negative. What is the reason that particles have charge inside a colloid? So क्यों होता है और why is that charge necessary for stability of a lyophobic colloid? So first of all, when we talk about the various types of colloids, so there is also one classification that is based upon charge. Then we'll talk about origin of charge. Then we'll talk about the stability provided by charge on colloidal particles, and there are some small properties which arise in a colloid due to the charge on the particles. Now, when we talk about the classification of colloids based upon charge, so there are only two possibilities, positive or negative. So, positive colloids are obviously the colloids which have positive charge on the colloidal particles, whereas negative colloids are the colloids which have negative charge on the colloidal particle. So, remember, it is the charge on colloidal particle, but the opposite charge in both the cases, opposite charge is present on dispersion medium. So means if it is a positive colloid, the colloidal particles have positive charge and dispersion medium has negative charge. Whereas if it is a negative colloid, then the colloidal particles have negative charge and the dispersion medium has positive charge. Some examples of positive colloids are the metal hydroxides and metal oxide colloids. So जितने भी metal hydroxide colloids हैं like FeOH whole thrice, AlOH whole thrice, CrOH whole thrice, all of these the metal hydroxide salts, they are all positively charged. तो यहाँ पे you may notice कि we have written colon Fe3 पॉजिटिव. ठीक है, तो व्हाट डू वी मीन बाय दैट, तो वो अभी बात आगे करेंगे, बट अभी के लिए जस्ट अंडरस्टैंड कि इट इज दिस Fe3 पॉजिटिव विच इज रिटन आउटसाइड द ब्रैकेट आफ्टर दैट colon that is providing the charge to the colloidal particle. Similarly, in the case of aluminium, it is Al3 positive. So these are some positive colloids. Also, it contains proteins in acidic medium and some basic dyes like methylene blue. In negative colloids, we have metal sulfide salts like arsenic sulfide, antimony sulfide, cadmium sulfide, which have sulfide ion written like this. So that sulfide ion is actually providing the charge. We'll study it is the ion which is adsorbed which is providing the charge. So we'll study because so here again this concept of adsorption will come in role. We also have acidic dyes and like Congo red, eosine, which are your negatively charged colloids. Then gelatin, rubber, starch, charcoal, clay, they are all negatively charged colloids. One very important point here is blood. So blood is a colloid beta. Blood is a colloid in which RBCs, that is red blood cells, have negative charge, and inside RBCs there is your hemoglobin. Hemoglobin has positive charge. So both of them are colloids but have different charges. RBCs have your negative charge, whereas hemoglobin has positive charge inside the RBC. So keep this in mind. Sometimes this particular concept is being asked, which is positive colloid, which is negative colloid. So what is the charge on dispersion medium in this color? So just remember, if the colloidal particle are positive, then dispersion medium is negative. Then what is the origin of charge? The charge present on a colloidal particles can arise from many factors. So some of them are due to presence of some acidic or basic group. It may happen that a compound, that a colloidal particle has some acidic group or basic group. It may happen that a colloidal particles are electrolytes. They may also capture electrons from their surroundings somehow. They may also arise, these get charged due to fractional electrification. And the most important point here for lyophobic soles particularly is due to preferential adsorption of a common ion. So that is what leads to charge. So one by one, let us talk about all of them. First, we'll talk about the presence of acidic or basic group. So when we talk about presence of acidic or basic group, some particles, some molecules of your colloid, they may contain carboxylic acid group or basic amino group. Now this carboxylic acid group or amino acid group may ionize inside the colloid depending upon the pH of the medium. Okay, so depend upon the pH of the medium, they may either form positive or negative ion. For example, if we have any amino acid like this in acidic medium, acidic medium means इसको क्या मिलेगा बेटा, H plus मिलेगा. So when it is acidic medium, it will get H plus from its surrounding. So कौन सा ग्रुप एक्टिवेट होगा, तो बेस का ग्रुप. तो यहाँ पे the base group NH2 will get H plus. So NH2 has a lone pair which can very easily abstract one H positive from its surrounding, and in an acidic medium it is very easily available, H positive is very easily available, so it will get that H positive and become NH3 positive. So क्या होगा, the entire molecule has now become positively charged. So this is what a positive colloid would be like. Okay, and similarly if the medium was basic, then what would happen, that COOH group may dissociate in the presence of a base. Okay, the base will come, OH minus will come and get its H positive and form water, and it will dissociate like this into a negatively charged ion in basic medium. So in acidic medium it may form a positive colloid, and in basic medium it will form a negative colloid. Okay, so these are mostly with amino acid or protein molecules when they are used to make colloid. Then next cause of charge is due to the self dissociation of the colloidal particles. We discussed in the previous lecture that some associated colloids, which are basically your soaps or detergents or acid or basic dyes, they in small concentrations they behave like an electrolyte. They may dissociate into ions, and as the concentration increases they may associate to form micelles. Now when micelle is formed, so beta when micelle was formed, so micelle may, this was the general, the tail was inward and the head was outward. Now different soaps may have positive tail or positive head, or negative tail or negative head. So depending upon different type of soap, the charge on the head and tail may differ. So the outer surface may have net positive charge or may have net negative charge, the outer surface of the micelle. So if the outer surface of the micelle has positive charge, that may become a positively colored, but if the outer surface has negative charge, then that will become a negative colloid. Okay, so that depends from which soap or which detergent we are using here and which dye we are using. Then the second method by which they may get charged is by capturing electron from its surroundings. So colloidal particles like smoke or clouds, basically they capture electrons from atmosphere itself. Okay, that is one of the reason why thunder happens in our surroundings. So that is the root cause of thunder striking, actually lightning in the atmosphere. So those clouds, they get negative charge from the atmosphere because they are colors, and that is quite possible. That is one way to attain a negative charge or any charge on its surface. Another method is by frictional electrification. तो क्या होता है बेटा, the colloidal particles and dispersion medium particle, when they may move inside the colloid, they may get friction. Because of that friction, we have studied something, some charge may develop, so that charge is transferred from one surface to another, and colloidal particles may obtain a charge with opposite to that of your dispersion medium. So now the most important concept from this particular lecture is that charge arising due to your adsorption, of some common ion. So mostly lyophobic soles have charge because of adsorption of some common ion on their surface. तो क्या होता है बेटा, इस तरह से we have a colloidal particle, it adsorbs some small ions on its surface like this. ठीक है, तो colloidal particle adsorbs some ions on the surface. तो colloidal particle पहले क्या था, न्यूट्रल था, बट आफ्टर इट एड्सॉर्ब्स सम चार्जेस, सेम चार्ज है ना, सब पे पॉजिटिव 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 ही एड्सॉर्ब हो रहा है, ऐसा नहीं पॉजिटिव भी कर रहा है नेगेटिव भी कर रहा है, नहीं, सिर्फ पॉजिटिव ही एड्सॉर्ब करेगा एंड इट विल अटेन सम चार्ज. सो कैसे होता है, फॉर एग्जांपल केमिकल रिएक्शन इफ वी सी, इफ वी हाइड्रोलाइज FeCl3 in normal conditions, we get precipitates of FeOH whole thrice, ferric hydroxide. That ferric hydroxide precipitate then adsorbs Fe3 positive ions from the solution. ठीक है, तो अभी सोल्यूशन में क्या आता है, थोड़े से अभी भी Fe पॉजिटिव के Fe3 पॉजिटिव के आयंस वो प्रेजेंट. तो क्या हुआ, वो प्रेसिपिटेट बना. प्रेसिपिटेट ने इमीडिएटली देखा कि मेरा एक भाई ऊपर घूम रहा है Fe3 पॉजिटिव, उसने उसको एड्सॉर्ब कर लिया. तो यहाँ पे क्या हुआ बेटा, Fe3 पॉजिटिव आयंस हैव बीन एड्सॉर्ब्ड ऑन FeOH होल थ्राइस. तो हमेशा सिर्फ कॉमन आयन ही एड्सॉर्ब होगा, या तो OH या Fe. ओके, now in this case, after this, if we instead of using water, if we used ammonium or basic solution, तो अगर हम अमोनियम हाइड्रोक्साइड के साथ इसको हाइड्रोलाइज करेंगे, then again what, FeOH whole thrice precipitates will form. Now in the ammonium hydroxide solution we have OH minus ions. तो OH minus ions get preference over Fe3 positive and they get adsorbed preferentially on the surface of these colloidal particles. तो यहाँ पे क्या हो जाएगा, if this is your FeOH whole thrice colloidal particle, above this we have multiple OH minus, so this is not one molecule, these are large chunk of FeOH whole thrice and उसके ऊपर बहुत सारे OH minus ions adsorb हो गए, such that the entire this particle is now one and it has a net negative charge. और इसके opposite solution में क्या होगा, solution में NH4 positive charge रहेगा in a dispersion medium, not in the solution, in the medium outside the charge will be positive. So the medium will have positive charge and the colloidal particle will have negative charge like this. Similarly, you can create charge in many other lyophobic salts as well. For example, if you have AgNO3 solution and you add Ki, ठीक है, in AgNO3 in silver nitrate solution we add potassium iodide. तो क्या करेंगे, if Ki is added to AgNO3, तो first of all AgNO3 and Ki will form AgI. AgI will precipitate, but then AgI precipitate will see what, कि the solution still contains Ag positive ions, because क्या हुआ है, हमने AgNO3 solution लिया and in that we have added Ki. तो Ki ऊपर से बाद में डाला है, तो थोड़ा कम डाला है, ठीक है. तो सोल्यूशन में मेजरली पहले क्या था, Ag पॉजिटिव. सो दैट Ag पॉजिटिव विल गेट एड्सॉर्ब्ड ऑन द फ्रेशली प्रिपेयर्ड प्रेसिपिटेट. तो उससे क्या होगा, द colloidal particles will attain positive charge. Instead, if we do the reverse, if we take Ki solution and we add some AgNO3, तो उसमें क्या होगा ना, the AgI precipitate will see कि मेरे पास solution में I negative ions are there. So that AgI precipitate will adsorb I negative ions and then it will become a negatively charged colloid. So you can see this is a positive colloid, this is a negative colloid. And then another common way to make charge on colloidal particles or make colloid is from sulfides. So cadmium sulfide, for example, if it is H2S is passed through it, then the cadmium sulfide precipitates, they adsorb sulfide ion. Okay, H2S में क्या है, sulfide is common, so the sulfide will be adsorbed on the surface of the cadmium sulfide particles and it will form a colloid like this. So what do we mean by this symbol beta? इस symbol का मतलब क्या है, that cadmium sulfide precipitate, on its surface we have sulfide ions like this adsorbed. Okay, it's not a neutral particle, and the outer dispersion medium, that is the outer phase, contains your H positive ions. Overall the entire colloid is neutral, but the colloidal particles have negative charge or positive charge depending upon how the colloid is made. So this is your origin of charge. Now let us study that if this charge is present, what exactly is happening in the ions there. So first of all, this is a, let us say we are talking about cadmium sulfide colloid. Okay, so we have a cadmium sulfide particle like this. In that, the sulfide ions, they are inside, and on the outer layer it has cadmium ions like this. So this is one colloidal particle. Overall, this is right now neutral. Okay, so right in the middle we have sulfide ions coated with cadmium ions. Overall, the particle is currently neutral. Now we have your, in your colloid, if you pass H2S, there will be some sulfide ions outside which are blue in color, and they will be attracted to this cadmium ion like this. So they will be attracted to this cadmium ion like this. So this becomes a fixed layer. This becomes a fixed layer of negatively charged ions. So क्या हुआ? The colloidal particle now has a fixed layer of negatively charged ions around it. So fixed layer means it will not move. So the entire that system, that particle gets negatively charged. And this negatively charged layer will obviously attract the positive ions. तो अगर sulfide ion था तो उसके opposite we also have some positive ions in the solution as well. So those positive ions in the solution may be H positive ions. Okay, those H positive ions may get attracted. So overall the solution is neutral, and in between there will be some negatively ions as well. So the second layer is not a fixed layer. यहाँ पे सभी बीच में मिक्स हो रहे हैं. Obviously the positive charge ion will be more. ठीक है, the positive charge will be more, but the negative charge will also be there. So in this second layer, इसको हम बोलेंगे diffused layer. Diffused layer basically contains ion of opposite charge. तो क्या हुआ? बीच में colloidal particle, उसके ऊपर कोई एक common ion is adsorbed. That adsorbed layer of common ion is the fixed layer. Now fixed layer has some particular charge. In this case the fixed layer is negatively charged. So if the fixed layer is negatively charged, now उसके बाहर there will be diffuse layer. Diffuse layer पे overall will be positively charged, but it will be mixture of both negative and positive. ठीक है, and बाकी the colloid is like this. So there are multiple such colloidal particles which are negatively charged. Okay, so this is what is happening. And now this two layer, if you see, there is a one layer of negatively charged particles, other layer of mostly positive, but बीच में कहीं कहीं negative particle है. So now there is a charge separation. Whenever there is a charge separation, there is a potential difference. Okay, so this particular, first of all, double layer is called as Helmholtz double layer. Helmholtz double layer. It has another name, that is Stern double layer, and the potential difference between this double layer is called as zeta potential. It is this potential difference that makes the colloid stable. So how does it make stable? If you have a colloid like this and there are particles which are negatively charged, तो क्या होगा बेटा? नेगेटिव नेगेटिव रिपेल. मीडियम इज पॉजिटिवली चार्ज, तो मोर पॉजिटिव आयंस आर प्रेजेंट अक्रॉस द मीडियम. तो क्या होगा? दिस नेगेटिवली चार्ज colloidal particles, they will repel each other. If they repel each other, तो बेटा how is a colloid more stable? Colloid will be stable if it, what you say, a colloid will be more stable if it does not get coagulate easily. Coagulation मतलब particles are not aggregating, particles are still trying to stay separate. वो एक दूसरे से दूर रहना चाहते हैं. अगर मिल जाएंगे तो कोएगुलेट हो जाएंगे, तो मिलने नहीं देना है। तो अगर उन सब पे नेगेटिव चार्ज है या सब पे पॉजिटिव चार्ज है तो क्या होगा, दे विल नॉट कम क्लोज, they will repel each other, all of them are positively charged, all of them are negatively charged, so that makes them stable. तो जितना ज्यादा अच्छे से ये चार्ज डेवलप होगा उतना ज्यादा colloid will be stable. If you do something to make them neutral or something by doing some adding some electrolyte in it, तो वहां पे this zeta potential gets destroyed and particles they aggregate together, or in other words they get coagulated. Okay, so this is how a charge provides stability. If the charge is there, particles repel each other. So due to charge, colloidal particles repel each other. Colloidal particles repel each other. Now, because of this negative or positive charge present on your colloidal particles, there are certain properties which arise. Such properties like electrophoresis. So electrophoresis kya hai? It is just like electrolysis of a colloid. It is like migration of charged particles of colloid under the influence of electric field. Okay, if the colloidal particles are positively charged, they will migrate towards cathode. If the colloidal particles are negatively charged, they will migrate towards anode. So hota kaisa electrophoresis? So it's normally a container or a U-shaped tube is taken. One side is basically cathode. Okay, one side is basically cathode. So let us label the left side as cathode and other side is anode. Okay, so if the colloidal particles are positively charged, if colloidal particles are positively charged, तो क्या होगा, upon applying current from this system, they will try to migrate towards the negative electrode, that is the cathode. तो सभी क्या करेंगे, यहाँ पे इस इलेक्ट्रोड के ऊपर जाके they will aggregate, स्टिक कर जाएंगे बेटा द colloidal particles. ठीक है, सो दिस इज व्हाट इलेक्ट्रोफोरेसिस इज. कहाँ यूज होता है बेटा ये, इट इज यूज्ड टू बेसिकली डिटेक्ट द चार्ज ऑन द colloidal particle. तो जिस इलेक्ट्रोड पे वी आर गेटिंग द चार्ज, दैट is very easy to tell which charge is there. If the particles are aggregating on cathode, we'll say particles are positively charged. If the particles are aggregating towards anode, we'll say particles are negatively charged. It is also useful to coagulate colloids. So many times we want colloids to be coagulated, ठीक है, for our purpose. So that is where it is useful. It is also useful to separate some mixed colloids. तो mixed colloids में क्या होगा बेटा, different colloidal particles होंगे. Different colloidal particles will have different mobility, ठीक है, because of the different sizes. तो कोई slow भागेगा, कोई तेज भागेगा. उससे क्या होगा, the ease of reaching the cathode or anode will be different. और हम अलग अलग colloids को वहाँ पे separate कर सकते हैं. Another point we want to discuss here is isoelectric point. तो previously we discussed the charge present due to change in pH. तो अगर high pH है, that is basic medium में क्या बना रहे थे वो, negative ion. यहाँ पे for example now any amino acid in acidic medium it will form positive colloid, and in basic medium it will form negative colloid. Now basic medium is above isoelectric point and acidic medium is below isoelectric point. What is this isoelectric point? That is where both the base and acid group of this amino acid or protein are ionized. So it basically exists in the form of a zwitter ion. So zwitter ion क्या होता है, जिसमें both positive and negative ionic sites are present. That ion is called zwitter ion. So at isoelectronic point, such colloidal particles are present in the form of zwitter ion, and at isoelectric point they are unstable colloids. Okay, they are least stable. So in this video what we studied, we discussed what are various positive and negatively charged colloids, what is the source or origin of the charge on colloidal particles, and how that charge is necessary for stability of lyophobic colloids. And major cause of charge is preferential adsorption of colloids. Also stability of colloid is discussed using Stern double layer, and we also discussed some properties arising due to the charge. It is electrophoresis and isoelectric point.